In a stunning development in the world of astronomy, the James Webb Space Telescope has detected something that has scientists buzzing with excitement and deep curiosity. This time, it isn't a glimpse into a new galaxy or the discovery of an early star formation. It's something far more mysterious, a supermassive black hole, drifting at incredible speeds away from its host galaxy. This discovery is not just surprising, it's transformative, shaking the very foundations of what scientists thought they knew about how galaxies and black holes interact. Black holes are often considered stationary, nestled at the center of galaxies, gravitationally holding billions of stars together. They are colossal in size and mass, and once a black hole is formed and settles into the center of a galaxy, it is expected to remain there. This is why the recent detection by JWST of a supermassive black hole moving at a staggering 4 million miles per hour away from its home galaxy is both mind-boggling and revolutionary. A black hole of this size and speed breaks the conventional rules and forces astronomers to rethink many aspects of cosmic physics. The sheer velocity at which this black hole is traveling is something to behold. To put it into perspective, 4 million miles per hour is fast enough to travel from Earth to the Moon in less than 4 minutes. It's so fast that it defies what we usually associate with objects of such immense mass. Normally, the more massive an object, the harder it is to move. But this black hole, weighing more than 20 million times the mass of our Sun, is not only moving, it's tearing through intergalactic space with a trail of stars behind it. Yes, stars. What makes this even more extraordinary is that the James Webb Space Telescope observed a brilliant trail of stars stretching out for over 200,000 light-years behind the speeding black hole. These stars are thought to be forming from gas that the black hole has compressed and ignited as it plows through space. This is not just a runaway black hole, it's a creator in motion, leaving behind a luminous wake of star birth that's longer than the diameter of our entire Milky Way galaxy. This incredible phenomenon may be the result of a cosmic collision on a scale so vast it's almost incomprehensible. Astronomers believe that this black hole was likely part of a system of 3 supermassive black holes caught in a gravitational dance. When galaxies collide, and they do, more frequently than one might assume, their central black holes can become gravitationally entangled. In this case, it's theorized that 2 galaxies merged, and their central black holes began orbiting one another. Then a third galaxy, with its own supermassive black hole, joined the fray, and the gravitational chaos that followed ejected one of the black holes, a runaway traveler, at breakneck speed. What's most fascinating is that this discovery was completely unexpected. Scientists using the Hubble Space Telescope initially noticed a strange streak of light emanating from a distant galaxy. It didn't match any known structure or phenomenon, and it piqued their interest. With the superior instruments on board the James Webb Space Telescope, they were able to zoom in and reveal the shocking details. This wasn't a typical jet of gas or light. It was a trail of new stars, and at the front of it, a black hole was racing into the abyss of intergalactic space. The implications of this finding are far-reaching. For one, it confirms that black holes can indeed be ejected from galaxies under certain conditions, something that was once theoretical but now observed. This tells us that the dynamics of black hole interactions are more complex and volatile than previously believed. It also opens up new questions. How many black holes might be wandering the universe, undetected and alone? Could there be other runaway black holes, perhaps even closer to our galaxy, that we simply haven't seen yet? Another crucial implication lies in understanding how galaxies evolve. If supermassive black holes are sometimes ejected, what happens to the galaxies they leave behind? Are those galaxies left with no central black hole, or do they eventually attract another one through future collisions? Could this process affect star formation, galactic stability, or even the shape of the galaxy itself? These are questions that astronomers will now pursue with renewed urgency. What makes this scenario even more remarkable is the fact that the speeding black hole is not destructive in the way one might expect. Rather than consuming everything in its path, it appears to be fostering the creation of new stars. As it rips through gas clouds in space, its immense gravitational influence compresses the gas, triggering rapid star formation. In essence, this black hole, which might have been expected to be a bringer of darkness, is instead illuminating the cosmos with new light. It is a paradoxical force, both a destroyer and a creator, reminding us of the strange duality that defines much of the universe. From a technical perspective, the instruments on JWST that made this discovery possible are among the most sensitive ever built. Its infrared capabilities allow it to peer through cosmic dust and gas, revealing hidden structures that older telescopes simply couldn't detect. This is yet another example of why JWST has been hailed as a revolutionary tool in space exploration. It's not just giving us sharper images, it's uncovering phenomena that completely challenge our understanding of how the universe operates. As we continue to process the data from this astonishing observation, astronomers around the world are busy crafting new simulations and models. They are working to understand the exact mechanics of the triple black hole interaction that likely caused the ejection. Using powerful supercomputers, they can simulate different collision scenarios to see which ones produce results similar to what JWST has observed. These models will help determine just how common such events might be and what signs we should look for in other parts of the universe. This discovery also underscores the importance of collaboration in science. From the initial detection by Hubble to the detailed imaging by JWST, this breakthrough involved multiple teams, telescopes, and researchers across the globe. It's a testament to the power of shared knowledge and collective curiosity. Science doesn't move forward in isolation. It advances when minds from different disciplines and locations come together to ask bold questions and follow the evidence wherever it leads. There is also a poetic element to this story. A black hole, traditionally seen as the ultimate trap, a region from which nothing can escape, not only escaped the galaxy but is now forging a path that creates new worlds in its wake. It's as though the universe itself is revealing layers of complexity that we are only beginning to understand. This runaway black hole has turned into a cosmic artist, painting a streak of stars across the darkness of space, defying every assumption we had about these monstrous celestial objects. As we gaze deeper into the cosmos, there's a sense that discoveries like this are only the beginning. The James Webb Space Telescope is still in its early years of operation, and already it has revealed ancient galaxies, probed atmospheres of distant exoplanets, and now discovered a speeding black hole creating stars in its wake. Each revelation brings with it a deeper sense of wonder and a reminder that the universe is far more dynamic, strange, and beautiful than we ever imagined. This runaway black hole may be just one of many out there. Somewhere in the vast darkness, more could be moving silently between galaxies, trailing light and stars behind them, waiting for us to discover their stories. And with telescopes like JWST, we are finally equipped to find them. As we continue this grand cosmic quest, guided by light from across the universe, who knows what other wonders lie just beyond our reach, waiting to transform our understanding of reality itself.